right, so we're going to add just a little bit, guys. We're going to add to the notes a little bit. So 11.4b. All right, we're going to start working with multiple angle equations. Right now there's a proving task scheduled for tomorrow, and it would only be on equations. If you guys want, we can do what we did last week and double them up on Friday. Do that? Okay. Yeah, so it would be a little bit more equations. All right. All right, so let's get this show on the road. So where does sine of x equal 0 again? When x is 0, and where's my other one? Pi. All right. Now, when we're dealing with double angles, okay, that's what starts weirding people out because they're like, well, crap, now there's a 2 next to the x. Now what do I do? Well, you're going to still use these same answers. So if we replace this with a u, u would equal 0 and pi. So x would have to equal our 2 answers for u divided by 2. Okay, so what's 0 divided by 2? Still 0. All right. Pi would turn into pi divided by 2. Because pi over 2 times 2 still gives me regular pi. Okay? Easy enough? That's literally it. All right. How many do we want to do ones like these? I can do that one. Yeah, I can go back up. Yep. So if we're looking at C, all right, replace this with u again. So u equals 0 and pi. So x would have to equal still 0 and then 2 pi because we need to double. Okay. Would it help if I wrote in because you're dividing by 2, you need to do the opposite and multiply by 2? If you need it, write it down. All right, so for D, again, replace it with U. Where does sine equal 1/2 on my unit circle? Pi over 6 and 5 pi over 6? Are we in agreement? I'm going to say, you guys should all know the unit circle. All right, so it's showing times 3, so I really need to divide by 3. All right, easiest way to do that is you multiply by 1/3. So I am left with pi over 18 and 5 pi over 18. Easy enough? All right. Now do we want to do the horrible one with sine squared and a cosine? Yeah, you're going to want to use purple sheet for this one. Yeah, we'll make this the last one. All right, ready? So before we get too far into it, again, I like switching them with you. So I've really got sine squared u plus cosine of u plus 1 equals 0. Now, I would probably switch something so that I can get it so I have the same trig function. So if I've got a sine squared, can I switch that to a cosine squared? So sine squared plus cosine squared equals 1. So sine squared by itself would be 1 minus cosine squared. So 1 minus cosine squared of u plus cosine of u plus 1. Alright, combine your like terms. Now notice that the cosine squared is negative. That's going to make factoring a little more difficult. So what I always tell kids is switch all of your signs all the way across, because let's be honest, trying to factor when your leading coefficient's negative kind of sucks. Alright, so we're going to make this positive, this one's going to become negative, and this one's going to be negative. So I've got cosine minus 2, and then cosine plus 1 equals 0. So I've got cosine of whatever u is equals positive 2, and then I've got cosine of u equals negative 1. Now, this first one, is that one on the unit circle at all? No. So, this would be an extraneous solution. Alright. Now, the one on the right, I can actually deal with. So cosine equals negative 1 at pi. But remember, my original was 3x, so x needs to equal pi divided by 3. Now, the next thing becomes, it says find all solutions. How often is this going to repeat? Every 2 pi. So plus or minus 2 pi k, or n, or whatever your little heart desires. Cool beans? All right. I have the worksheet already made for you guys.